It is time. Good afternoon, everybody. Oh, that was pathetic. Come on, guys. You are the biggest class here in person. We've got to take advantage of that. Good afternoon, everybody. Good afternoon. Oh, so much better. So much better. All right, we're going to have a fantastic day today because on your end, it's going to feel kind of relaxed and chill because I'm going to do a lot of the talking, probably all of the talking. However, it is not relaxed. You cannot just chill. You are doing the most important step of the learning process, the feedback phase. We are going to go over the answers to last week's homework. There were several very tricky questions in there. And your job today is to diligently go through your own work. Check what you got correct. Pat yourself on the back. Yay, I got that one. Check what you got wrong. And then you need to understand, okay, why did I get this one wrong? What did I do here? What does Mr. Apple say it should be? Why is that the case? Why is it supposed to be that one and not the other one? You said it's true. I thought it was going to be false. Why is it true? Mr. Apple, can you explain number 7? I didn't get that one. That is your job. You need to ask those questions, if not out loud, at least internally, until you understand. I want it to be 100% obvious why the correct answer is correct. If it's not, we need to stop and explain it more. Okay? Because that's how you learn it. That's how you'll study it and be ready for, well, there's going to be a test eventually, right? Okay, with those expectations laid out, we'll start at the beginning, I guess. We could start at the end and work backwards. But we'll start at the beginning. Yeah. So here we go. Number 1. Determine which of the following are statements. All you had to do was say yay or nay. What's your name? That's not a statement. That's a question. It's got a big question mark on it. Dead giveaway. You didn't have to say why. You don't need to write question here. No is sufficient. Or not a statement. B, the rain in Spain falls mainly in the plain. Ends with a period. That's a sentence. Okay, but is it a statement kind of sentence? Is this a thing that it would make sense to call true or false? Yeah, you could say, oh, no, false. It doesn't fall mainly in the plain. It falls mainly in the subtropical forest, right? So yes, that is a statement. C, Happy New Year. No, that's an exclamation. Not even a full sentence. There's no subject verb there. D, 5 is an odd number. I agree with that. That sounds true. Oh, hey, I can say true or false and I don't sound crazy. Yes, that's a statement. Right? It'd be a little weird to say, Happy New Year, false. What? I can't say that's true or false. Number 3. We're going to take use these statements to translate the symbols shown into a full English full English sentence. Noticing that the caret guy means and. The upside down caret, the V, means or. The arrow, they make theirs double thick in this textbook, that's okay, means if then. And the tilde means not. And with these statements there, you're going to get 3A. Roses are red and the sky is blue. Exactly like that. 3B. Roses are red and the sky is blue or turtles are green. It doesn't have to be exactly like that. There's a little bit more wiggle room here. You need these 3 statements in that order. They need to be connected by and an or in that order. But the extra bit, right? I added a comma here. Because originally, they had grouped these 2 together and then attached it to this one. So the best way I could represent that written out would be to comma separate this half and that half of the sentence. But parentheses work completely differently when written out. Right? It's more like for an aside statement, not grouping things. You could also say, roses are red, and it is the case that the sky is blue or turtles are green. That'd be another way to do it. C, if the sky is blue, then both roses are red and turtles are green. Should be pretty much exactly like that, because the if then already sets us up with this nice comma separation into the two halves, two groups of statements. D, if turtles are not green and turtles are green, then roses are not red. Roses aren't red, then it is not the case that roses are red. That could work. You also don't need to say turtles twice. As long as the subject didn't change, you could say if turtles are not green and green. If turtles are not green and they are green. If turtles are green and not green, you can swap the order on the ands. That doesn't make a difference. Any of those would work. Questions so far? Okay, let's keep going. Number 4. We're doing the same thing but backwards now. Here's the full sentence. Turn it into symbols. A, if it is raining, then the sun is not shining. Q, arrow, tilde, P. I would, of course, read that as if Q, then not P, or Q implies not P. B, it is raining and the grass is green. Q, caret, R. Q and R. C, the grass is green if and only if it is raining and the sun is shining. We didn't talk much about if and only if before, but it was in your notes from this reading, from this text. So I need you to be able to recognize that, call that one out. I'm not going to ask that you use it in your own arguments. That's fine, but you need to be able to see it and at least be able to do this with it. It just means you can do the conditional both ways. If P, then Q, and if Q, then P. Right? The converse is, in fact, true in this case. So we can say if and only if with the, I think, the bidirectional arrow. It makes that more obvious. Oh, I can go in either direction. So in this case, R, double arrow, Q and P, Q caret P. The other shorthand we have for this, if and only if gets written out so much in math class that mathematicians decided it's too much work. I'm going to shorthand it, and we call it IFF. IFF. So if you ever are reading math stuff and you see if with a double F, it's not a typo. They mean if and only if. One bit of trivia there. Not necessary in this case. Double arrow. D, either the sun is shining or it is raining. P, VQ. And this right here is a good reason. Do not use the letter V as a shortened statement, right, to stand in for a whole statement, because you're going to confuse it with the symbol for or. Right? Your handwriting is not as clear and distinct as the typed font and symbols on the computer. So don't risk it. Just don't use the letter V. Right? Just like we don't use the X to multiply now that we're in algebra and X is a variable. Right? We start doing dots and parentheses and all that. Okay. Next up, the first big chunk where questions will probably occur. Number 7. We are told P is a true statement, Q is a false statement, and R is a true statement. Find the truth values of the following combinations. A, P and not Q together is true. B, it is not the case that P or Q. That is false. Other side of the cabinet. C, not P implies R. That's true. D, not P and R, biconditional with Q. Really hard to translate it. If and only if, not P and R, then Q. That's true. E, not Q and P or R. That's true. This or R really saves us. I really didn't care what's in there. R is true. I can pick it. The whole thing is true. F, P or if and only if Q then R. That's true. G, R and not Q or R and not Q. I said that. No, sorry. R and not P or R and not Q. True. And H, P and Q implies Q or not R. True. All right. What questions do you have from that section? None? Really? You mean you got them all 100% correct? Or now that I've shown you the answer, you can just look at it and be like, oh, yeah, that's clearly obvious. I don't know what I was thinking before. I'm 100% certain I could do that again on the test, no problem. 100%. There's no lingering doubt in the back of your mind about any of these. Okay, for the record, there's a lingering doubt in the back of my mind about that fact, but you say so, we'll go on. If at any time that state changes, feel free to email me. Number 11, state the hypothesis or hypotheses and conclusion for each of the following arguments. All right, as usual, you're going to start with hypotheses and end with conclusion. They made it really easy here. All football players are introverts. That's a hypothesis. Tony is a football player. Hypothesis. And Tony is an introvert. That's the conclusion. They flagged it for you with the so. So, Tony is an introvert. Therefore, Tony is an introvert, right? Clue words. Also, it's at the end. Every argument should end with a conclusion. Everything before that is probably a hypothesis. Unless, of course, it's a much longer argument, in which case you have one argument leads to the next argument, leads to the next argument, you chain them together, and there's some conclusions in the middle that become hypotheses. We don't have that here. Bob is taller than Jim. Hypothesis. Because the only way I can know that is if I tested it somehow ahead of time, right? I have to know this outside of the argument to make that claim. Right? We measured him. Bob is taller than Jim. That's our hypothesis. And Jim is taller than Sue. We had to have measured them. So Bob is taller than Sue. That's our conclusion. We can know that one is true by way of the logical reasoning. We don't have to measure and compare Bob to Sue because we already have those other facts, right? That's another way you can tell the difference. Can I get this information from the other pieces, or do I have to independently go test it myself? It's generally why we have logical arguments in the first place, is so that we can arrive at new pieces of truth without having to test everything. Because sometimes you can't, right? In the case of the courtroom scene, right? They can't go back in time and figure it out and check firsthand, so they've got to work their way through the reason. All right, 13. Here's a full argument. Determine whether it's valid or not. All professors are handsome. Do you think a professor wrote this book? I think so. Some professors are tall. Therefore, some handsome people are tall. That can happen. That's totally valid. Right? Think about drawing a Venn diagram. All the professors end up in the handsome zone. Right? Some of them are also tall. So all those tall professors are still in the handsome area. So then there are some handsome people that are tall. They're the professors. But that's valid. That's a law of syllogism, mostly at work there. You're looking at me funny. You need me to draw it? No, your eyebrows are furrowed. You're good? Okay. B, if I can't go to the movie, then I'll go to the park. I can go to the movie. Therefore, I will not go to the park. While this may actually happen in real life, you might say such a thing. It is an invalid conclusion. Because you've completely ignored the possibility that you go to the movie and the park. Right? You didn't say you wouldn't go to the park beforehand. I can't conclude that. I could still go to both. It's just if I wasn't going to the movies, I would only have the park left as my option. Didn't say I couldn't do both. So that's invalid to conclude that. Because it didn't say I can't do both. Right? It's all about ruling out possibilities. Okay? Your conclusion is valid when it's the only possibility left based on the logic. Right? So you think of, is there a counterexample? Right? You say, therefore, I will not go to the park. Wait, could you still go to the park? If I did, does going to the park invalidate any of these? It does not. Right? It doesn't contradict it. So that is an invalid conclusion because it's not guaranteed. Good question. Here's another one. People love to use this kind of thing all the time. If you score at least 90%, then you'll earn an A. If you earn an A, then your parents will be proud. You have proud parents. Therefore, you scored at least 90%, right? That had to be the case, because everybody knows that's the only way your parents could be proud of you. No, invalid conclusion. You can't just go backwards. These have an order to them. If this, then that. If 90%, then your parents will be proud. Or, if you did really well at the sports game last week, then your parents will be proud of you. Or if you finally cleaned your room, then your parents will be proud of you. Or you got your driver's license, then your parents will be proud of you. Right? There's all kinds of ways your parents can be proud. It didn't say this is the only one. Right? Talking about eliminating possibilities. Right? Is that the only way it could have happened? No. So it's invalid conclusion. D, some ARPs are bumps. All bumps are certs. Therefore, some ARPs are certs. I have no idea what they're talking about. Those words make no sense. It doesn't matter. I don't need to understand what they're talking about. All that matters is the structure. It follows the structure of law of syllogism, so it's a valid argument. It's valid. Doesn't mean it's sound. I don't know if that's true. I have no clue about ARPs and bumps. Can't say any more than that. But it's valid. If that's the case, I'll give it to you. Here's one I do know a little bit more about. All equilateral triangles are equiangular. It's true. All equal angular triangles are isosceles. Also true, right? If 3 angles are the same, then yeah, by definition, 2 of them have to be the same. Okay. Therefore, all isosceles triangles are equilateral. No. Again, you can't just go backwards. We were going equilateral, then equal angular, then isosceles. In that order, in that direction. Now I was trying to say all the isosceles go back to equilateral. Invalid. You can't just reverse it. And if you know anything about triangles already, you'll know that's the case. I can totally draw a nice long, skinny equilateral isosceles triangle. It's definitely not equilateral. The fact that I can come up with a counterexample. I know these are true. I can counter this and say, no, that's false. Therefore, it's not a valid conclusion. See how that works? Okay. Here's another one. If you work hard, then you will succeed. Sure. You do not work hard. Alan, how could you? Therefore, you will not succeed. You ever had somebody tell you that? You don't work hard. You're not going to succeed in life. Excuse me, that's an invalid conclusion. I can still succeed in life. You don't know me. Maybe I'll get super lucky. Somebody will hire me. I'll become a movie star anyways. You don't know. Maybe you've got some super rich great uncle you've never heard of that dies and leaves you $1 million. Who knows? Right? Maybe you define success differently. Staying at home in your basement playing video games all day. Maybe that is success for you. I don't know. Okay. That's invalid because there's more than one way to succeed. Yeah, hard work will get you there. It's not the only way to get it's the most likely though. Honestly, as your teacher, I have to remind you that please do still work hard. It's the most likely course of action to lead to success. It's not the only way. Technically, it's like 95% of the way. So this one's 5% invalid, all right? G, some girls are teachers. All teachers are college graduates. It's required by law. Therefore, all girls are college graduates. No, so close. Oh, they almost had it. It's like, it's got the right structure. Girls to teachers, teachers to graduates. Therefore, girls to graduates. It looks great. That's law's syllogism right there, except for this. You started off as some girls are teachers. Now you're telling me all of them are college graduates? No. You can't just suddenly generalize like that. That's invalid. H, if it doesn't rain, then the street won't be wet. The street is wet. Therefore, it rained. Totally valid. Modus tollens right there. Questions on that section? All right. Next one. Using the pair of statements, determine whether P is necessary for Q, or P is sufficient for Q, or both. All right, so in the first case, our statement P says Bob has some water. Q says Bob has some ice. Okay, we got to interpret this. This isn't just structure-based. This requires a bit of knowledge here. If I have some water, is that necessary for then having ice? Really? If you want ice, don't you need water first? I mean, you could like buy both of them separately from the store, I suppose there. But to make ice, to get to ice, don't you have to, somebody had to start with water first, right? Yeah, you got to have water in order to create ice. We're talking about regular ice, solid H2O, not like dry ice, okay? All right, so it's definitely necessary to have the water. Is it sufficient? Can you make ice with only water? Is that the only thing you will need? If I hand you a cup of water and say, here, make it into ice, you are not allowed any other tools, devices, techniques, materials. Then you need cold, right? I can't just have, you can't just turn this into ice right now. Not right here, not right now. You can't just look at it and be like, be ice, okay? Doesn't work that way. You got to use a freezer or go somewhere where it's really cold, right? That would be a freezer, right? So it's not sufficient. Just having water doesn't do it. You got to have cold water. You have to wait to remove thermal energy from it somehow. So there's something else needed. It's not sufficient. Does that make sense? B, statement P, it is snowing. Q, it is cold. Is snowing necessary for cold? No, we don't need it to be snowing in order for it to be cold. It's cold outside right now, and it's not snowing, right? Therefore, not necessary. But is it sufficient? Is it enough to know that it's snowing to conclude it must be cold? Yeah, if you look outside and you see snow coming down, you are guaranteed, oh yeah, it's cold out there, right? That's the nature. Again, it's similar to the water ice thing, right? If you can see the particles of water have frozen solid into snow crystals and they didn't turn into rain on their way down, it is still cold enough outside. So number 2, it is sufficient. All right, finally, C, it is December. 31 days from today, it is January. Okay. Is December necessary for 31 days later to be January? Yes. It has to be. You can't get to 31 days later in January from any other month, right? If it was November, we can go really close. November 30th, 1 day off. Yeah, but 31 days later, you're on December 31st. Oh, shoot, that's no good, right? You won't get to January, right? Or you could go to the very end. December 31st plus 31 days, we're still in January. But you go one more, January 1st plus 31 days, now we hit February, right? No good. You got to be in December to still land in January. So it's definitely necessary. Is it sufficient? If all I told you right now, it's December, I don't know which day, but it's in December. Any of those days, if I add 31, am I always in January? Yeah. Then it is sufficient, right? That's all I need to know. It's definitely going to work. So both are qualified, 1 and 2, so we can say I, necessary and sufficient. Questions there? All right, keep going. 17. Which law is being used in this argument? We're going to assume they gave us valid arguments to check here. A, if Joe is a professor, then he is learned. You don't hear that term a lot. If you are learned, then you went to college. Joe is a professor, so he went to college. That's mostly law of syllogism right there. Again, we're treating this in the simplest possible case. So I'm looking at one hypothesis, first sentence hypothesis, second sentence hypothesis, treat the whole third sentence as the conclusion. So it's still in an if-then format. If Joe is a professor, then he went to college. So the whole thing is a syllogism. You could then further break down this last statement, be like, well, they didn't say if here. They just said Joe is a professor. So really they're making that asserted as another hypothesis. The final conclusion, he went to college. So it's a law of syllogism plus a modus ponens. because modus ponens is also law of detachment, right? I took, instead of treating this as one conditional, I detached the conclusion. He went to college is now my conclusion all by itself. And you'll see that again on C. That's why I wrote it there. Syllogism, okay, syllogism plus modus ponens, depending on how you want to treat that. Right? They're treating these mostly as one argument, one-step arguments. That's fine. So with that in mind, B, if you have children, then you are an adult. Bob is not an adult, so he has no children. That right there is a contrapositive. So the law of contraposition. Or you could say, well, I took the contrapositive and then did modus ponens. Or you could say the whole thing is a modus tollens, which is that other one. I didn't call out modus tollens from this text. Right? So that works too. Contraposition or modus tollens. I'll accept either. C, if I am broke, I will ride the bus. When I ride the bus, I am always late. I'm broke, so I'm going to be late. Law of syllogism to combine those conditionals. And then, yes, another modus ponens, really, to get that final, well, this isn't an if. It is a now apply this specific case. This is true. Conclude the final conclusion separately, modus ponens. All right, 19. The final giant list of true and falses. A and B are both true. P and Q are false. X and Y have unknown truth values. Ooh, sneaky, sneaky here. So some of these are not determinable. Some of them have an unknown truth statement in them, but you can still figure them out. Use your truth table. Check each possibility. Okay, if X is true, this thing is true. But if X is false, it's still true, right? If either way works, if you get to the same answer either way, you can make a conclusion there. No? Let me go through them and then ask. All right, so if P, then A or B. That's true. Either way, I've upheld the bargain there. If B, then P or A, also true. But if X, then P, that's unknown. I can't tell because P is false. My conclusion is false. I need to know whether or not X was true before I can determine if this was a good conditional or a false conditional. I need to know whether or not I broke the promise. That was the phrase they used in the text for determining if a conditional itself is true or false. Did you break the promise? If X was true, true led to false. You lied to me? This really happened. And then you didn't do the thing like you said you were going to do. How dare you? Right? False conditional. But if X was false, false led to false, that's okay. Right? You can conclude anything from a false premise. Nonsense. If pigs could fly, then the grass would be red. Well, I mean, the grass isn't red, but pigs can't fly either, so it doesn't matter. Yeah, sure, that conditional's true. We have no way to prove it's not. D, A or P, true. I always get to pick the best one. E, if B, then Q, false. You broke your promise. How dare you? F, if B, then X. That's unknown. I don't know if you broke it or not. Yet to be determined. G, A and B or X. That's true, because of that or there. I don't care what X is. I can just pick B. Either or. I get my choice. H, Y or X leads to A. That's true. Because, again, doesn't matter which one I actually pick. You get a true statement. Right? Either you started with nonsense and it worked out okay, or you started true, ended true, held the promise, all works out. I, y and b leads to p. Oh, that's unknown. Don't know yet. I need to know if you held your bar, your end up or not. J, a or x leads to b and q. That is false. K, if x then a, true. Yeah, it doesn't matter which way x is. Both options leading to a true statement are true. L, x or p, unknown. Don't know which one to pick. Do I get the option of picking a true one? M, if not x, then x. Unknown. I really don't know there. I don't know how we started, and I have no idea how we finished, so I don't even know if I needed to know how we started. I don't know what I don't know. That's very unknown. N, x or not x. Oh, this is a lovely one to know, right? Even though I have no idea what the truth value of x is, this is always true. X or not x, always true. Because whatever x is, I could just choose the opposite. Right? If it was true, I can pick the opposite. If it was false, I can pick the opposite. Right? Either way, I get to pick one version that's true. O, also kind of nifty, y and not y would always be false. You are never going to be able to get a thing and its opposite to be true at the same time. That's preposterous, right? Y and not y would always be false. And then we negated that whole thing, so it turned out true. All right, questions on that section? No? Still thinking? All right then, last one. Great big Euler diagram. Check these statements. I would just, create a dot inside the circle and check what other circles we're in. All women are mathematicians. Okay, any point inside the women's circle, is it all inside the mathematician circle? No. What about these ones out here? False. Euclid was a woman. This dot is not in that circle. That's false. All mathematicians are men. Nope, that would be, here's some that are women. False. All professors are humans. Professors, all inside the humans. True. Some professors are mathematicians. Here's your professors. Some of them over here are in the mathematicians. Yes, true. Euclid was a mathematician and human. Euclid, in the mathematician circle, which is all in the human circle. So yes, that's true. Final call for questions. On the document here, or the oh, okay. I'll look into that. To edit the version that you uploaded? That's weird, because it still should be your document. Oh, interesting. I didn't realize that. Okay, yeah. Yeah, okay. All right, I'll take a look at that. Any content questions then? Let me cover those first, then we'll get to the technical bits at the end. No? Okay, one other thing I will point out here. I have uploaded some samples from Friday's classwork, the My Cousin Vinny logical arguments. And I just went through and pulled out some that I liked. I just thought they were either well stated, or a few of them were actually caught me by surprise. I'm like, oh yeah, I didn't even think of that part as a logical argument, but someone found a way to format it so it works. The most common errors I saw with these were either you didn't include enough content in the first place. Some people wrote or highlighted or copied one sentence and then tried to label that as an argument. It's like, you need to have the rest of it there to say that this is a whole argument. So that was one issue. Or they misapplied the rules of logic. All those examples of the invalid arguments, those were the different ways. They either tried to run the conditional backwards and call that true. It's like, no, you can't do that unless you're negating and calling it modus tollens, or they called it modus tollens, but nothing was actually being negated. And so that was another issue there. So here are some good examples. So do take a few additional minutes later today and read through these and see how they compare to what you found. Some of the more unique ones, we've got the classic, right? Like, if you make grits for breakfast, then it took 20 minutes. Therefore, it didn't take you 5 minutes. Law of syllogism. Well, that's pretty close. What they're not writing out here is, if it takes 20 minutes, then it didn't take you 5, right? It's one of those things that goes unsaid. Well, of course, it can't take you 20 minutes and 5 minutes. So right, that's one of those unwritten statements, but it's implied there. So you get a law of syllogism that reduces that. The other one I really liked here was this one, modus ponens here. If Vinny wants Lisa to explain, then he will say, I would love to hear this. Vinny says, I would love to hear this. Therefore, Vinny wants Lisa to explain. This is technically going backwards, right? This is not modus ponens. But I love the drawing out away from the dialogue, right? This isn't just the actual argument as presented in the courts. This is taking a situation and saying, hey, somebody did a thing because of this. Right? Anytime you can make that type of statement, something happened because of, you can turn it into a conditional, right? Because he said, I would love to hear this, that means that he wants her to explain. There's a cause-effect relationship there. You can write that as a conditional. That's what this person did. So I thought that was a clever identification there. All right, I think I hit the button to let you share, so try it now, or let you edit. That seems so strange to me. I don't know why they, probably to lock you out, like I submitted it, and then before the teacher actually gets to grade, you're still in editing things and adding answers in. That's probably the case. Anyways, homework this week, you've got 2 lessons on study.com about logical fallacies. Those should be fairly fun. People always like to find ways of telling people they're wrong, so enjoy that one. And then tomorrow we practice writing out full-on arguments from scratch. And in 2 weeks, you have your test. Not this Friday, but next week, Friday, the end of the quarter. That'll be your final, not final, but the logic unit test, okay? End of the quarter. It's coming. This Friday, I will post a review packet for you. So you'll have the long weekend to work on that in order to review and prepare for said test, okay? Yes? Yes. Yes. Okay. Anything else? All right, then it is 2:30. You are dismissed. So long, farewell, enjoy the rest of your day.